Okay, I've got 2 o'clock. We're going to go ahead and get started. Thank you, everybody, for attending this month's Contractor ABU Online. The topic today is stairs, corners, and curves. It is probably one of the most popular questions we get, whether that's through our contractor certification classes or just even technical inquiries via email and phone calls. So I'm glad to see everybody in attendance here. But just as a reminder, our Contractor ABU Online is the third Tuesday of every month. We do send out reminders for the pertinent topic, but you'll get a chance to comment or maybe even advise or recommend a topic in the email that I send you as a follow-up, which will follow shortly after this session. But what I want to do is outline some of the things that we're looking at. Obviously, for curves, corners, and stairs, there are a lot of things that can go wrong. And so I want to communicate some of the problems we've seen in the past and talk about how you can resolve some of those. I will outline the proper requirements or requirements when you're considering curves and corners, because obviously that lends itself into stair application. And then obviously I'm going to conclude with the stairs. By all means, I'm going to qualify this. We do not have all of the answers per se, but I do want to give you an overview on things to consider as we move forward. And so I want to start with recognizing that there is a problem, right? We know that the curves, corners, and specifically stairs are an issue. Why? Because it complicates layout. It's real easy to do a straight wall with easy access, and once you get your base course in, you're stacking and backfilling. But whenever you have your corner or stair application, there's additional layout things to consider, and that makes it problematic. And then the next thing that I want to just recognize is that every product you use is different. And because of the product's nuances, that changes your layout, that changes how you can do things. And yes, Allen Block products are pretty similar when you're looking at across the Allen Block family, but I also know you guys get pulled in a lot of different directions and you may not always be using Allen Block. So recognizing the product limitations per se or characteristics is so important when you start looking at these three topics: curves, corners, and stairs. So before I get started, I just want to give kind of a word of caution. We know that you guys are all very often are following plans or set of plans or even the layout that the homeowner might be requesting, and it's easy to draw straight lines. And so we tend to, when we're doing engineering training and architecture, working with architects, get them to realize when you draw a straight line and put a funny angle in there, that's a mitered cut. That is a joint in the wall that's going to create a vertical seam all the way from the beginning of the first course to the end of the last course. And so what you see here, and if I get my pointer out, you'll see that we have a mitered joint right here in that wall. And actually they did a pretty good job, but you've got two different walls trying to go opposite directions. And so for that, we try to get you guys as that contractor to look at recommending doing curves and radiuses because they are faster to build for you. And quite frankly, for us, it's structurally stronger. So anytime you can work with your customer, try to get them to look at that curve instead of these mitered joints. And there's a lot of reasons we try to avoid these mitered cuts, right? I mean, not only does it slow you down, but it costs you money. We've talked to numerous contractors from across the coast, from coast to coast, and talking to them, I've heard anywhere from a cut anytime they see that saw fired up or they got a guy on that saw, it's costing them $3 to $5 every time. And so we know that those cuts cost you time and money. So let's try to avoid them, and that's where these curves and radiuses really come into play. And then at the bottom of the slide there, I got to just bring in the point. Most of you guys are aware that OSHA has definitely changed their standards. If they see dust generated on a site, that is a violation. So they are looking everything to be wet sawed and have a plan to handle the concrete dust. You can no longer just fire up the saw and make that cut and let the plume of dust, silica dust, filter over the neighborhood. And granted, we don't have a lot of OSHA inspectors driving around streets all the time, but that is the requirement. If you are generating dust, that is a violation. And we'll probably have a whole separate Contractor ABU Online specifically about these standards and what to consider. But I do want you to be aware of that and make sure you guys are not caught unprepared. Okay, so let's start with the easy one, curves. Since we are recommending curves, we definitely want you to bend these walls around any kind of point. For Allen block specific, it makes it pretty easy as long as you keep the faces nice and tight. You can turn your outside radius right here just by knocking the wings off. And there is a right way and a wrong way to knock a wing off. We want that face down and then go ahead and knock that wing towards the face. By doing that, you keep the core of the block intact. If you've ever done it and experimented with this, if you take it from face to the back and knock it the other way, the concrete breaks a little bit and you pull a little bit more concrete with it, and you can actually create a weak point in that block. And so we just try to make sure everybody on the job site understands face down, hammer it towards the face, and now you're knocking the wings off. So that's outside radiuses. Obviously inside radiuses, no mystery behind here. You can see, keep the faces tight, but then just go ahead and spread out the back wings to make that radius and effective. But it's important to understand that when you do radiuses, you got to know the products you're working with. And what is that radius? Well, obviously you're coming off of that straight wall. Here you can see that 90-degree edge, and then you're striking that line around that curve to determine what is that radius or that length that you're looking at. And so here you can see that radius is going to change as you build that wall, especially with any kind of a segmental retaining wall that has a setback to it or a wall batter. Those two terms are interchangeable. That setback forces that radius to get tighter as you build that wall. And I know we've got some experienced people on the phone here. You've seen that. And so then it's so important to understand that every time you lay this wall out, you need to know the characteristics of the block you're using. And we've got the design charts just like everybody else. I recommend you, when you're using the product like Allen Block, go ahead and check that commercial install manual, the radius charts. You'll see a link in the follow-up email, but here's on page 57. I just took a little excerpt from it. But let's just focus on like the AB Classics at 6 degrees, which is this row right here. You'll see that if I start my radius at the bottom, the tightest radius I can make, and that was shown in the other screen, is at 4 feet. Well, I can't start at 4 feet at the bottom. I would have to start, let's say if I'm building that 5-foot-high wall, it tells me I need to build my bottom radius at a minimum of 4 foot 4 inches. That way, by the time I'm up in the air, my top of my wall, I've got that 4 foot radius at the top. And you see how that changes with the different products you might use. For example, that Jumbo Junior, which is the half length unit. So instead of 18 inches in length, you're looking at a block that's only 9 inches in length. And notice that that radius is so much tighter. I can start my radius at 4 foot 3 inches and be just fine because my minimum radius for that Jumbo Junior is closer to 2.5, 3 feet. And so understanding the products really helps really helps in the layout, and that way you can go ahead and make some changes through this. I know a lot of contractors, again, I keep generalizing because we get the benefit of talking to guys on different sites. I know a lot of contractors that try to keep most of their radiuses around that 10-foot mark. Part of it is then it's consistent, it looks nice and fluid, and they don't have to worry about the blocks kind of pinching up on them towards the top of a wall because that 10-foot minimum radius would actually kind of feather it out very nicely. But it's important, like I said, understanding the products. Here you're looking at a nice project when you're seeing this beautiful Abbey blend wall using the Europa collection, some tumbled characteristics, but you see it. I know your eye is just as trained as mine, but right there when they had to get it close to that steps, they had to turn a tight radius, and now they're using that half-length unit to tighten up that radius. And again, your perspective, my perspective might be a little bit different. Obviously, I think they probably could have done something a little bit better to keep that pattern running through there. But at the end of the day, it's all about keeping your customers happy. So obviously this contractor was able to do that by tightening up that radius using that half-high unit. And so using a blend of products, there is absolutely no reason why you can't mix the full size or your half-length units together to kind of turn around these corners. And that's one way to kind of solve that problem. When you're talking about curves, I definitely got to put this little nuance characteristic out there. When you do these really tight radiuses with your full size block, you got to remember these are 18 inches in length, and you're trying to do a 4-foot radius. You're going to see that the blocks kind of have touch points to them. They're going to be hitting the blocks below it, for example, here and here, and that's going to force the block back where it could actually expose the top of the course below it, and so you can see that lip. Um, Aesthetically, that's the problem. Structurally, there's no issue with it. So this is an aesthetic fix that you can make, and it's outlined in our commercial install manual as well. That you can actually modify the block. You can deepen the notch, and it's important to deepen the notch. Never modify the lip. The lip is our shear key. That is our setback. So you always kind of make the modifications towards the bottom of the block, where if you deepen that notch, that allows you to slide that block forward and hide that setback or that top of block, and it still maintains that 6-degree setback. So again, all aesthetics, non-structural, but kind of another reason why I know a lot of contractors try to avoid the cuts by keeping their radiuses pretty large. You know, like I said, 10 foot or more, and now they've got nice fluid curves, and it's easy to kind of make the product work regardless of the product. And like I said, if you're turning a radius with any segment retaining wall unit that's 18 inches in length, you're going to have these pinch points out there. So kind of be smart in how you do that layout, and that way you can avoid the cuts, which obviously cost you time and money. I'd be remiss anytime I do a training class not to talk about the reinforcement, because we know the block is just a facing to that element. So the geogrid is in place to reinforce the soil. If the soil can't move, now we've got a stable structure. So in my contractor training classes, I often refer to no gaps, no overlaps, meaning that we need 100% coverage in the wall with the grid, so that way we don't have problems. And so when you're doing this inside arc, you're going to get a rectangular shaped grid, and around a fluid curve, you're going to get these gaps. So you can kind of see here, you got these triangle shaped wedges, and it's not like you're going to have you and your crew cut that wedge. In fact, make it simple on you. Go ahead and make a note, use a soapstone or a chalk line or something to go ahead and mark where those wedges are, and then just simply put another layer of geogrid over the top of it. That way you're preventing that gap. Again, no gaps, no overlaps. Then on the flip side, when you're talking about these outside radiuses, again, a rectangular piece trying to go around a fluid curve, you're going to see that it pinches up on you, and now you're going to have an overlap. And most grid companies out there, when I talk to their technical assistants, they say grid on grid could be a little bit of a slip surface. So now all of a sudden you don't have that interaction with the soil, and it's not as desirable as you're getting that gap or that overlap. So what we want to do is just simply lift the top layer of grid up, put about two or 3 inches of material between there, and then put it right back down. That way we've got the grid soil grid interaction and not that slip surface that they worry about. But again, no gaps, no overlaps. We're in good shape. The last thing I want to talk about curves before I move on is when you do have the option to do a pattern wall, and I do recommend giving it a shot. It's one of the easiest ways to distinguish yourselves from competition and kind of take your projects to the next level. Here's a beautiful ashlar pattern wall in a stream area, but with patterns, you've got blocks that fit together, and we've got different preset patterns, whether it's 2 courses, 3 courses, or even a 4-course pattern. When you're doing curves, you want to use a 2-course pattern. Why? Because it's just like that setback pinches the wall when you're doing that outside radius or when you're doing that inside arc and it starts to fan out on you. You're going to be fighting that setback a little bit. And by doing a 2-course pattern, and what I mean by 2 courses, that 8-inch increments, so 16 inches, if you look close at this picture, you'll see that we've got a horizontal line running through this wall, and then 16 inches above that, or 2 blocks, you've got another horizontal line. That is a 2-course pattern that is showing a way to turn these radiuses without having to fight that setback, because every time you do a pattern, it resets. So that way, now you're not having to cut or chip or modify the block to do that pattern. If you're doing straight walls, obviously a 3-course or a pattern is no problem, but when you're doing radiuses, 2 courses is always easier. Okay. So when we're talking corners, that's our next transition. You definitely got to be smart about your layout. Here, you're going to see this project a couple times. I had to. It's the wall that I built at my first house. So you can see it's a little bit of a complicated layout. I've got an inside corner. I've got an outside corner. I even have a set of steps that I'm starting to build over here, and you'll see some finished shots of this. But realizing when you have corners, if you've got two or more corners, you're going to cut some blocks. Let's face it, you've got a fixed point of return on either side. You've got a fixed length of block, about 18 inches. That means you're going to be cutting. And if you're going to cut block lengthwise, I would highly recommend don't make that cut right at the corner. In fact, if you look at any literature, if you go on to any job site yourself, even ones that you've done, it is very natural for your eyes to go to a corner. It's just a point of return, and so it's just natural for people to focus on that return spot. And so try to make your corners look outstanding. You can make that cut, maybe go 2 or 3 feet back, being the meat of the wall, and that way the cut isn't right next to the corner. And I guarantee you're going to be happier with the result. It's just a way to raise the bar, increase your professionalism, make it look outstanding. That cut, hardly anybody will ever notice if it's in the wall, as long as it's not in that corner. And like I said, you're going to be making that cut if you got multiple corners that you're working with. So let's talk about these corners here a little bit. When we do that inside corner, so here we got the face of the blocks being shown, it is the only time you're going to see or have anybody from Allen Block recommend to modify that top lip. Otherwise, that top lip is off limits, like I mentioned before. But all we're simply doing is removing the portion of the lip that is embedded into that wall. So we just kind of score the lip here and remove it. And you can cut it as it shows in the upper left-hand corner. Otherwise, I know guys that just hammer and chisel it, so they just make that score mark and then they just knock it off because it's buried. It's no big deal. And then on the next course, you just go ahead and go the opposite direction, so you kind of zip the blocks together and create a nice structural inside corner. One word of advice, just keep in mind as you do these inside corners, the walls tend to sit back a little bit, right? You've got that setback. So make sure you've got a little bit of a block buried there. So that way you've got the next courses on top of it will go ahead and rest on the block. If you simply stopped your block right here, now all of a sudden you'd have an issue. So I always kind of make sure you just got enough block into the hillside, and that way you're not a problem. Okay. So let's talk about it. I did the grid for curves. I got to do the grid for corners. All we're going to do is just go ahead and change that where that grid is going to be located. The best thing is don't stop putting the grid right where the faces stop. You need to extend the grid into that hillside, so that way we've got this inside corner reinforced as well. The minimum depth that we want to see is 1/4 of the wall height. So take that wall height, multiply by 0.25. I know a lot of contractors that just extend it to whatever the grid lengths are, but the minimum depth is 25% of the height. Obviously, the next layer of grid up, so 2 courses spacing, you're just going to go ahead and lengthen it the other direction. Again, very similar to what you did with the block. You just kind of overlap it. It's the same thing with the grid. Okay. So let's talk about outside corners, because this is really where a lot of guys spend a lot of time. We've got a 90-degree corner block for most of our collections. With outside corners, you do have to worry about that corner separating. Let's face it, you have 2 walls trying to go opposite directions. And so you've really got to make sure that corner is nice and tight. Make sure you're using some geogrid reinforcement, and we'll talk about that a little bit. Now for Allen Block, we've got a couple different things to consider. We've got rights and lefts when it comes to corners. And you'll notice in our literature, we don't tell you which one's which. We just tell you that in corners, you're going to be using both, right? You can see here, we've got a corner that's going one direction and then the other corner going the opposite. So when you're doing a corner, you're going to be using both rights and lefts, and they kind of balance out. Where it really comes into play, and some of you guys, again, based on the experience, you know that you're going to be finishing your wall. A way to transition that 8-inch step down, you use a corner. So that's why it's so important that you work with our production partners out there, because you would think it'd be consistent, but it's not. Every producer might have their own way of looking at and identifying their outside corners, whether it's a right or a left. So just make sure you're on the same page there with them as you go ahead and order these for finishing the walls. But like I said, corners, you're just going to go ahead and stagger that. As most of you guys know, laying your base, it is much easier to do a step up than a step down. So try to find your lowest point possible when you lay that base course and work from there. But once you got your base course in, I would suggest try to find your corner. Start your next courses at your corner. That way you can use full-size block and not have to make that cut right at the corner, and that might eliminate some of the headaches that you have dealing with the corner. So again, always start your base at the lowest point if at all possible, and then your following courses, go ahead and start at that corner and work away if at all possible as well. I do want to put a little clarification out there with the corner blocks. Yes, it's got the lip on both sides, which makes it structurally strong, but the notch might have to be cut out in the field. Not all of our producers are this way, but you might have to cut that short notch. And there's a tech sheet on how to do that, but or what depth it is. But all you're doing is you're creating that setback so it models the 6 degrees, or some of you guys use a vertical block in both directions. Some of our producers are able to manufacture it that way, but not all. And that is a true limitation of the equipment that people are using out there. And so I want you to be aware of that. And that should be a question that you have with our production partners, is find out what those corners come out as. If you have to make that cut, I want you to be aware of that, because again, I know cutting block costs you time and money, and you shouldn't have to pay for that. That should be a pass. You pass that along and you adjust your quote to that customer, because the last thing I want you to do is not be as profitable because you got a surprise because of a product. So double check with our production partners, but know that going in that short side might be a cut out there just to go through there. Not all of our products have that requirement. If you've ever used our AB Fieldstone, it's our first generation of non-split. The beautiful thing with this, the way it's manufactured, we create what is called 812 units. And these 812 units, one of them, then they're manufactured 4 at a time, but one of the 4 has a 90-degree edge. And with that 90-degree edge, you can do that outside corner, as you can kind of see here, very easily. It's not a separate block. You just grab it off the pallet and you can put it right in the wall. The Fieldstone is a 2-piece system. All that means is you use the anchor units. That is the locking mechanism. And when we do corners, all we do is we bridge over. So we lock these 2 blocks together by bridging between the units with that anchor. We would adjust. We just make that correction right here. Eventually, we want to get back to 1 face, 1 anchor. But in that corner, we like being able to bridge it so that way it's nice and locked and it's a nice sound corner. So keep that in mind. Again, getting back to the products that you're using so you understand the nuances. And again, literature is so important and make it useful. I got to talk about grid when you're talking about outside corners, because there is an additional thing to consider. Besides the no gaps, no overlaps, you need to know what type of grid you're using. There are different types, and specifically the strength direction is so important. If you're doing smaller walls, I would strongly recommend you use what is called a biaxial geogrid. And biaxial means it has its strength in both directions. So that means is they usually come in 3 or 4 foot rolls by 50 feet long. You can roll it out parallel with the wall, and being strength in both directions, you can go ahead and start that next roll and go this way with it, because I don't have to worry about its strength. It's always the same. Uniaxial grid. So when you're doing taller walls and you need that additional stronger grid, you're going to be using uniaxial grid, which means it has strength only in one direction. And that's the sheer sign right here. If you ever have a grid that's got a machined edge or a thickened edge to it, that means that's a uniaxial grid, or very commonly, and that has to go perpendicular to the wall, and you cut it to whatever the design length is. So as you can see here, the strength is going this way. It is not going this way, which means this is a little bit of a weak point if you're looking at reinforcing this face. So what we try to do is we get to the designers, we talk about to the engineers, where we say, let's stagger the grid in that corner. We're going to come in on courses like 1, 3, 5, and 7, but we'll leave on courses 2, 4, 6, 8. Now we can take that grid, roll it the opposite direction, and we've got grid reinforcing the corner in both directions, and it's structurally sound. So that is a lesson that our production partners and Allen Block is doing with the design community, hopefully trying to make your job a little bit easier so you're not second guessing where this grid needs to be placed. Okay, so one last thing with the GeoGrid, this is these grid details really haven't changed forever. I mean, I've been with Allen Block for almost 18 years, and these details have stayed the same. And the beautiful thing is they don't change on what product you use as well. The big thing is no gaps, no overlaps. We extend it into the hillside. Biaxial versus uniaxial, they are very consistent regardless of the block facing you're using. So whether you're using the Classic or the Jumbo Junior or the new Aztec, it all functions the same. What has changed, and this is just recently, you might see in this figure, and this is right out of our best practices manual, it is really looking at the outside corners and curve. We know that these outside corners and curves are a little bit of a weak point in a segmental retaining wall. And so what we do is we want to bring in more rock at that point. And if you're thinking rock is just the drainage zone, you're missing some of the functions that rock does for you. The reason why we put that rock behind the wall is not only for that drainage, it actually aids in compaction and consolidation and helps the stability. So what we're doing in these outside corners and curves, we actually increase the rock depth. You can see it's just H over 2 in both directions. So that way you can get better consolidation in these outside areas, and it leads to a better wall. And you'll see that recommendation in the industry's best practices document. It's a push for a zero wall failures initiative that we have, and the best way to do it is make sure you got consolidation right at the face. But you guys are doing some incredible stuff out there. I mean, I look at this project. This is a project up in Canada, British Columbia, and there's a lot going on here, right? We've got outside corners, we got inside corners, we got inside curves, we got outside curves. Obviously, it's leading to a set of steps for the grade change, but there's a lot of things that you guys get pulled into, and quite frankly, I don't think you guys get the credit that it deserves. I mean, can you imagine laying this wall out and determining where all these steps and locations are going to be? And so you can do that as long as you know the limitations or how the block works. And there's a lot of things that we can do. So we're going to transition to stairs now. And I keep monitoring the questions. If you do have a question, feel free to go ahead and type it. I'm watching that too. So keep that happening if you need to. But stairs, what could go wrong? You know, that's the $1 million question. The problem is every set of steps is different, which means every set of steps could give you your own source of headache. Here's two set of steps that we're trying to go up the grade. One is very fluid and very expansive, so the treads are much wider, where the other one is very dynamic, where it's got steps every 12 inches and it's going up the hillside much faster. So every set of steps is unique. So before I get into the steps, I've got to talk about the code. Okay, the International Building Code, IBC 1009.3, outlines what are the stair and tread riser requirements. And I've got it highlighted here. The one that's easy to meet is the stair tread depth. That's the 11 inches. Well, most of the caps are 12 inches in depth, so that's pretty easy. It's the stair rise that we got to be conscious of. And in that, if you look at the IBC, you'll see that the maximum rise is 7 inches. Well, that's great, but most of the segmental retaining walls out there are over 7 inches in height. They're looking at 7.5, 7 3/4, even a true 8 inches. And so when you're working with products like that, you might have to keep your blocks or your stairs independent of your wall. Here's a case. If you look pretty closely, you can see that the stairs are actually not tied to the wall itself. They built the wall, and then they did the individual steps between there, but keeping them at 7 inches as opposed to 7 3/4. And you'll see that the wall is slightly taller than the stairs, and that's because they're keeping this true 7 inches all the way up. Okay. Keeping them independent allows you to use different products, whether it's a natural stone or here's another segmental retaining wall that's solid. And so you can just go ahead and bring that in. Again, independent, keeping them at 7 inches. Truly, if you're looking at that code requirement, I know guys, especially if they're doing commercial work or some residential work in cities that require cast in place steps. Okay. I love using segmental retaining walls because it keeps that solution dynamic and you can really work with it. But here you can see they cast the steps first and then they butted the walls up to it. And so there's ways to provide that solution, especially when you're talking about code compliance. But I do know from firsthand experience that a lot of the building inspectors really aren't looking at stuff like that for residential jobs. Now, I'm not telling you to go out there and break the code, but or not follow the code, but just keep in mind that you might have to look at these stairs for the IBC. And these stairs, man, they can really change and function differently. There's so many different set of steps to really be dynamic. For example, on the left-hand side here, I tend to refer to these as fill applications because you're filling in front of the wall with stairs, whether that's curved or rectangular. That really depends on the aesthetic look. I tend to call these cut sites that are perpendicular into the wall because you're cutting into the hillside to make room for the stairs. Here, these are parallel. They're actually running parallel to the face. Yeah, we're doing some inside and outside corners to facilitate the stair rise, but really the sky's the limit. And so I really want you to be aware of what is the rise. It's usually that block. So if you need to keep it independent, go ahead and make that change. As far as treads, we'll get into that a little bit. There's a lot of different options for you. Obviously, a lot of people use the caps. If they're trying to make it a little bit more free-flowing, they go caps and pavers. I know guys that do a lot of paver work, and they just do all pavers. Myself, what I did is I did concrete because I was matching the concrete driveway that I was pouring in. And so you just take a little note and pour that concrete in the core a little bit and finish it that way. But stair tread is important. I'll give you a couple examples. Here's a project that we did up in Canada. Again, it's with the Aztec collection, non-split, but you can see the fill steps in front of it, independent of the wall, and they just went ahead and did very abrupt steps, 12-inch step tread depths right up the hillside. And so that way they could make that transition. On the flip side, here they did a little bit of both, right, to kind of create that flowing stair where they did 12-inch steps here, but then they did a little bit of a switchback to go parallel with the wall and then up the hillside again. Again, trying to make it work. You get into a set of steps like this where you're blending all your knowledge. Again, you've got right up the hillside because that's what the grades are showing, but then you can kind of make it a little more fluid as you work down the gradual hillside here. And again, like I said, I don't think you guys get enough credit. You look at a lot of projects like this, the engineers look at this and they have no idea where to start. They see a blank hillside where you guys see it. Well, okay, I can curve the wall in here. I can bring the steps out. You're accenting it with some pavers. You guys are doing some incredible stuff out there. And I'm not trying to pat you on the back. It's just truth. You guys are doing some great work and don't get enough credit for it. Here's the steps that I built. Don't be too critical if you look at it, but I just did that inside and outside corner over here, if you remember, and then I just feathered each course off and fanned it out to create the stairs. And then I just did some 90-degree returns and started building my secondary wall to retain that soil. Obviously, it's not done yet. I still had to put the railings and stuff on there when this picture was taken, but a great way to build a set of steps when it was all said and done. Here's another application where this was an award winner for the Hardscape North America set of steps where they did tiles, kind of blended it out, entryway into here, and then they used the setback and hid the setback by curving the steps around the wall itself, because that's important. We want to try to make them look as natural as possible, whether it's an ashlar pattern or a regular pattern. But whenever you do your stairs, just use the full-size blocks. Make it as easy as possible. Obviously, you can see in this picture, there's really no reason to carry a pattern into a set of steps. You don't even see most of the facing units anyway. That might sound obvious, but I've seen contractors try to be overly creative, and it just causes them problems. I always call this picture kind of the trifecta. You've got the paver work, you got maybe even some above wall features like a courtyard and seating walls, but then obviously you got the retaining wall to create the grade changes for the patio and requiring some steps. Again, being creative, getting out in front, putting a little bit of a fill application in here to make that grade change happen in the short space that you had. All right, and that's important. Keeping in mind what space you have, you can see right here, all you're looking at is your natural grade. What is the height that you've got to traverse? And then you're just dividing that height by the rise or the block height. Might be 7.5, might be 7.75, might be 8 inches. Here the example shows 8 inches. So if I've got a 4-foot high wall, I divide it by 8. That tells me I need at least 6 steps. All right. Now, if I can spread that out over a gradual hillside, then I know my treads could be a little bit wider. If it's got to be tighter together because they just don't have the distance, then you're just doing nothing but caps. So that's the key, right? You know the tread height, or you know the riser height, that's your block. Then you got to just determine what is that tread depth. And that's the element to the stairs that you need to determine. And then obviously during construction, you know, I got a note down here, and you can see it. It says, "Don't get cute." It's easy for me to draw these nice, clean, crisp lines in a detail, but to be perfectly honest, you're going to blow this all out when you're building stairs. Remember, this is a point of traffic, and so you're going to have people walking on there. So go ahead and bring in more rock than you typically use. And so what we want to do is just make sure we've got a base that is level, base that is compacted, base that is sound. That grid, I showed you how to use grid in curves, corners, and stuff like that. Ironically, I tend to recommend grid in stair applications because what does grid do? Grid holds soil together. And so even if you use that biaxial grid and just kind of lay it even at an angle here, that holds that soil together. So instead of acting as individual courses or individual steps, it acts like a staircase. It acts as one element, and it moves together that way. So that grid is great. You know, I'm full of a lot of sayings because I do the contractor training. I'm like, when in doubt, grid it out. I tend to put grid on just about anything out there, and that includes maybe even your base of your stairs. But then you just go ahead and make sure the block's level. You can see you need to determine where that next tread depth is going to be, because that's where your next block is going to be, and then it's just leveling that up. Obviously, using the block below it as your point of reference, so that way you can continue to make your consistent step up. And you just go ahead and make sure you repeat those steps as you install the caps and pavers or pour concrete all the way through. But like I said, I like making sure your base is nice and sound. I like making sure that you've got some grit in there. I know guys that will, if I use this bottom picture as an example, they'll dig out this whole area and they'll even bring in block below it to make sure they've got consistent. And that holds true. If you can rest it on additional block, that helps. That's one of the reasons why I'm not trying to push fieldstone, but one of the advantages of the long anchor unit we have is now it's 24 inches deep. So therefore you can rest the next block on top of the one below it, and it just helps you with that layout, helps with that base installation. And that's what they did here. A beautiful project where they just used the long anchor units in the stairs so the next rise could be put right on top of that. The way they finished it up, since it was kind of a switchback and non-uniform, they just poured concrete in the cores and kind of finished it off right on top there as a great way to finish that set of steps. So keep that in mind. Always try to figure out if there's ways. One other thing as far as stair construction, we know there's going to be a setback to this wall. In fact, if you're using the 6-degree product, whether it's a pattern wall or the AB Classic or anything like that, the setback is for every wall height in a foot, you're stepping back about 1.25 inches. Okay. What does that mean? Is if you are doing these 90-degree returns, your bottom step is going to be shorter than your top step. Okay, you can see a lot of times that's not a problem. You look through our pictures, you'll see that all the time. But if a customer truly wants that vertical return, as you can see in this picture, that is going to be a modification to the block. There's just no way around it. You guys are going to have to cut block. And what I mean by cutting, that means deepening the notch. Remember, we don't want to remove the lip. The lip is the shear key. So you're deepening the notch, which allows you to slide that block forward. Well, we keep coming back to every time you fire up the saw, that costs you time and money. So you have to adjust your bid accordingly. So make sure when you're talking stairs with your customers, you show them some pictures of past work, of things you've done, so they get an idea of what to expect. If they're looking for those vertical returns, that's an adjustment. I know guys are, again, being pretty creative. They'll just throw some pillars in there. And by throwing some pillars in there, they've got that vertical return, and then they can bring in the steps, and it kind of hides that setback. But in other words, you can let layout do it for you. Here, they're just doing some parallel steps, switching it into the hillside, so it's not just one big wall, and so they're allowing the steps to be more free-flowing instead of a vertical. And this is a great example here where they're just taking some terraced walls and feathering it out, easy for me to say, but feathering that here, so that way it's not just one consistent stairs where it looks like it gets taller or longer and longer as you move up. They're using the terrace to kind of reset and look a little bit more like an hourglass, which is a great way to hide when you do your layouts in your wall. And so keep that in mind. The blocks do have a setback. Like I said, for the classics, it's about 1.25 inches per foot. And once you know that, it makes it a lot easier for you to lay that out. Here's another example where they just kind of did a couple terraced walls to work through that and kind of blend that together. All right. Okay. So showed you a bunch of pictures here. Again, getting pretty creative on how you can kind of use layout to help you with the stairs. I definitely got to talk a little bit more, or one last thing, about maintenance. Some of you guys get involved with maintenance all the time. That's part of it. In fact, here in Minnesota, we're coming off of one of our worst winters, especially February of all time. The maintenance guys had a hard time keeping up with the snow. It seemed like every day we were out there shoveling snow. And unfortunately, what that means is a lot of times they're throwing salt down to melt the snow and ice to make sure people don't slip. Any concrete product, I don't care if you're talking a sidewalk or an Allen block or a paver, they don't like salt. That freezing and thawing will deteriorate concrete over time. I mean, look at what those of you that live in northern climates and they see salt on the roads. What do you think all these potholes are from? I mean, that freezing and thawing condition is really hard on hard surfaces like concrete and asphalt. So what we try to do is we try to, especially on residential jobs, try to get the homeowners to think about more sand, a sand blend than a salt mix. In fact, what I'm going to do, we've got a text sheet that's called Caring for Your Retaining Wall. I'm going to go ahead and attach that to my follow-up email here. I know a lot of contractors, as they're working with homeowners, they leave that text sheet with them as kind of that final walkthrough and final blessing, because it talks about, keeping it clean, pulling a weed once in a while, and it really specifically talks about salt use around on pavers and retaining walls. So use that for future use and try to make sure you don't have the problems that might be associated with salts deteriorating concrete over time. All right. I mentioned a couple times throughout the presentation, we have installation guides. This residential piece is great for smaller walls under 6 feet, which a lot of times you guys are getting used to and doing. Biaxial grids being referenced in there. If you're doing taller walls, we've got the commercial install manual, great piece. In fact, I'll include links to both of those. Use that as a point of reference, but just keep in mind there are resources available to you. We always want to make sure that there's training. We do contractor training classes across the country every year. If you're new to this, or if you've got guys on your crew that are new to this, have them attend. the contractor certification class. It's so important to understand how these walls work and develop that knowledge. Obviously, you've got the engineering team here in Allen Block Corporate. Again, like I said, we don't have all the answers, but we get the benefit of networking with producers around the globe. And we do retaining walls every day. As fun and exciting as that sounds, that's what we get to do. And so use that knowledge. And there's a good chance that your application, we might have seen something similar, and we'd be happy to give you some pointers or things to consider as you're working on that project. And then, of course, allenblock.com, that website, second to none. It's got a lot of resources to it. It's all mobile friendly. So when you're on a job site, if you feel that you want to just look through a text sheet or watch a video, there's a ways to do that at allenblock.com. In fact, if you go to that website, there's a Google search tool right in the upper right-hand corner. You can type in stairs, or you can type in corners or curves, and it'll give you all the links right there that you can kind of feed through. And there's videos that you can watch to help you with this. But with that, I do want to just kind of thank you again for your time. Again, the Contractor ABU Online is every third Tuesday. Please when you get my follow-up email, let me know if there's topics you want to consider. But at this time, I'm going to kind of conclude, and I'm just going to hold for about 30 seconds here and see if there's any questions. There hasn't been any that have popped in, but if there's anything specifically you want to discuss, let me know. But otherwise, I wish you the best of luck out there. I know the season is starting to break in a lot of markets, and we're expecting a pretty good year. So let us know how we can be a resource, and I appreciate everything you guys do and considering using Allen Block. Thanks again.